The second law of thermodynamics. Kelvin-Planck statement. And Clausius statement. Observations. The Kelvin-Planck statement and the Clausius statement, heat engine and heat pump statement respectively. This statement is related to heat pump, heat engine and refrigerators. Three observations should be made about these statements. We have three. Three observations should be made about these two statements. The first observation is that both are negative statements. The first observation, let me make a correction. Is that both are negative statements. It is of course impossible to prove these negative statements. However, we can say that the second law of thermodynamics is based on experimental evidence. Impossible to prove these negative statements. The positive and negative statement is, however, the purpose of negative is, for example, for a Kelvin-Planck statement. It is impossible make our sentence negative to have a heat engine, for example, that convert our input heat to work, or impossible to have a heat engine with the efficiency of 100, and therefore Clausius we have it is impossible. To have a heat pump that transfer heat from a low temperature to high temperature one without input work. However, we can cite that the second law of thermodynamics is experimental, based on experimental evidence. Every relevant experiment that has been conducted either directly or indirectly verifies the second law, and no experiment has ever been conducted that contradicts the second law. The basis of the second law is therefore experimental evidence. A second observation is that these two statements of the second law are equivalent. The Kelvin Planck and Clausius statement are equivalent. As the second observation. Two statements are equivalent if the truth of either statement implies the truth of the other, or if the violation of either statement implies the violation of other. So we can write two statements are equivalent if the truth of either statement implies the truth of other, or if the violation of either statement implies the violation of the other. For more description about this statement, consider this picture that shows this picture. The left is a refrigerator, that requires no work and thus violates the Clausius statement. This picture. The W is equals 0, so it is impossible to transfer Q from, for example, a low temperature to a high temperature reservoir for a left part. This violates the Clausius statement. Let an amount of QL be transferred from the low temperature reservoir to this refrigerator and left the same amount of heat QL be transferred to the high temperature QL. Let an amount of heat QH that is greater than QL be transferred from a high temperature here transfer the temperature to the heat engine and let the engine reject the amount of QL as shown here, right? Heat pump. As it does an amount of work QH minus QL, because there is no net heat transfer to the low temperature reservoir, the low temperature reservoir along with the heat engine and the refrigerator can be considered together a device that operates in a cycle and produces no effect other than the raising of weight and the exchange of heat with a single reservoir. Thus, a violation of Clausius statement implies a violation of the Kelvin-Planck statement. The complete equivalence of these two statements is established when it is also shown that a violation of Kelvin-Planck statement implies a violation of Clausius statement. This is left as an exercise, for example, for the student. The third observation is that frequently, the second law of thermodynamics has been stated as impossibility of constructing a perpetual motion machine of the second kind. Frequently, the second law of thermodynamics has been stated as the impossibility of constructing a perpetual motion machine. Of the second kind. A perpetual machine of the first kind would create work from nothing. perpetual machine of the second kind of the first kind would create work from nothing or create mass or energy thus violating the second law. A perpetual machine of the second kind perpetual motion machine of the third kind, a perpetual motion machine of the second kind would extract heat from a source and then convert this heat completely into other forms a source and then convert this heat completely into other forms of energy. Thus violating the second law. And a proportional motion machine as third law third kind would have no friction and thus would run identically but produce no work. Infinitely but produce no work. A heat engine that violates the second law could be made into a perpetual motion machine of the second kind by taking the following step. Consider this picture. Consider this picture, which may be the power plant of a ship, for example. An amount of QL is transferred from the ocean to the high temperature body by means of a pump. We have ocean here. With using a heat pump, we transfer heat to the high temperature body. The work required is W prime, and the heat transfer to the high temperature is QH, and it is W prime. Let the same amount of heat be transferred to a heat engine that violates the Kelvin-Planck statement of the second law and does an amount of work equals to QH. So this process violates Kelvin-Planck because all the heat converted to the work as amount of QH minus QL is required to drive the heat pump. This W net, leaving the net for Q W net equals to QL available for driving the ship. Thus, we have a perpetual motion machine in the sense that work is done by utilizing freely available source of energy such as the ocean of atmosphere. This is the end of the observation of the second law. The reversible process in the next